Is the wood really radioactive? Pull up a seat, nerds. We're talking plant biology. I'm so glad you asked. So to preface this info dump, this is my best guess. I'm not an expert. I'm a little bit of a scientist because I went to school for it, but I have a message into my friend who is the botanist for the DCNR, and she's very smart. She knows a lot about a lot. So I will have an expert verify this soon, I hope. But here we go. Okay, I'm about to info dump on the glowing properties of things, and I'm going to touch on about 4 different topics that I have no business being an authority on. It's just I'm really interested in this stuff, and I have looked it up, and I know a bit of the science. But if you are an expert in the field of plant physiology, mining and geology, biology, physics, chemistry, and anything I say is inaccurate, please correct me, because I need to be right. I don't need to win an argument, but I want to be right in what I say. And this is so cool and fascinating, and this is why I love science. We're talking about glowing things in this video, whether it's going to be a bowl made out of a wood that comes from a plant that glows, or a little figurine made with a glass that has an inclusion in it that makes it kind of glow during the daytime. As a side note, as I've been collecting this glass, knowing that it was made pretty much like in the beginning of the 1900s, why people thought it was so special, because they didn't have UV lights yet. And, you know, these weren't readily available on Amazon. We didn't have Amazon. And I grew up in the 80s and 90s where like nobody really had a UV blacklight in the 80s, and in the 90s, you were really cool if you had a blacklight in your bedroom and like the posters and stuff would come up. Although I knew like hippies in the 70s used to, and they were invented at the turn of the last century, and they were made commercially in the 1930s, which is around the time the Depression hit, and they made depression glass, and they put uranium and all these other additives in glass. That still didn't answer my question of why would people want glowing glass if they didn't even really readily have these available yet. They didn't, not commercially. Perhaps this was a city thing, someone who knows their history of the United States and like the cities and the countries, and Vaseline glass and depression glass and uranium glass can answer me that. But the science behind it, I've seen 2 different things. One is that, okay, so you can kind of see that this glows. I mean, just barely. It might just be my eyesight, but like, you know, the difference between my glasses or my fingernail polish, look at the way that throws light. Part of it is from the actual material it's made out of because it's glass. The other part is that I do have UV filtering in here, and it's getting close to midday, I think. And at noon is when more UV light reaches through our atmosphere. But I also read a couple of articles that there's something to do with sunrise and sunset, and like the curvature of the earth being a lens, and the angle of the UV light coming in at sunrise and sunset causes like a special wavelength of UV to pass in, and this will actually glow a little bit more. I haven't been able to test that. It's like a cool notion for me to think about. Can you imagine being in the roaring 20s and having a little speakeasy type party in your house, and then the sun starts to set and that UV light starts to come in your windows and your glassware starts doing its thing? I also just got word back from my botanist friend. She says, I don't know why some wood glows under UV. I would be looking at the internet too. We also have bioluminescence, which happens on its own. So this is all kind of stuff that glows by itself in nature without human intervention, or if you put UV on it, it glows by itself. And there is UV that exists outside of these little guys. I'm going to get way deeper than anybody cares about. The question is this bowl really radioactive? Well, there are a lot of reasons that things may glow. Of course, radioactivity is one of them. That's because of the radioactive decay is actually emitting a white light as it's doing its thing. And some things decay a lot faster than others. So radium decays a lot faster than uranium does, and the radium girls were the ones who were painting the clock hands because the watches could glow. The soldiers could see the time while they were in their foxholes. Radium excites nitrogen to emit white light. Uranium doesn't do that. Uranium actually has a really slow rate of decay, so if someone were to take me to a uranium mine or say, we wouldn't see those rocks glowing even under a UV, calm down. Even after we exposed uranium ore to UV light, it wouldn't be glowing. If you had a Geiger counter, you could see its radioactive emissions. And by the way, a lot of things emit radioactivity, and isotopes matter. So although it is pretty safe to handle uranium ore as I've understood it, there's actually just as much of a concern of contaminating the ore with what's on your hands. You just don't know what you're pulling out of the ground, so you do treat uranium ore as though it were a very hazardous material. Shoot, I just got a phone call. I got company coming over, so I gotta do this faster than I wanted to. Things tend to glow because of a lot of reasons. Like they're hot. If you get a piece of metal really hot, it's gonna glow because it's heat and it's expressing that energy as light. Some things glow because of radioactive decay. When you see the cartoons of the radioactive materials, the proper isotopes glowing is because of the properties of that material. Some things glow because of chemical reactions. I said that about the fireflies in my oxygen video because they've got a chemical inside their abdomen that mixes and it excites the atoms in there to a higher energy state. And when they go back down to the resting state, it's at that point that the flash happens because they're releasing the energy that was made in the chemical reaction as it goes back to its neutral state. And that's kind of what happens with uranium, as I understand it. Uranium oxide, like I said, uranium by itself isn't particularly reactive to UV light, but uranium oxide is. But I don't think it has to do with its radioactive properties. It has to do with those orbitals, like the chemical reaction in the fireflies. It's things changing at the atomic orbital outside layer and then going back to a neutral state, and then changing and going back to a neutral state. That's when the glow occurs. And then some things glow just kind of because of the way they're built. And when it comes to the wood, and there are different types of wood that do this and different areas of the wood that have flavonoids in them, which are phytonutrient compounds. Flavonoids and carotenoids are stuff that plants create that do thousands of jobs. Many, many jobs are when you think about the chemicals in plants, there's so many. Oh my God. Okay. Flavonoids do thousands of jobs. Everything from defense to UV light to herbivores to like giving the flavor of the plant to the medicines inside of a plant, like think antioxidants and all the things that people say you should eat your fruits and vegetables for. Some is for neural health, some is for heart health, some can help you cardiovascularly. You always hear about antioxidants, and they're a phytonutrient. And I read just now that it's the flavonoids. Sometimes there's a mineral sequestering in the wood that causes it to glow, but overall it's the flavonoids that cause stuff like acacia wood and locust wood to glow. I did a really cool experiment in one of my plant biology classes where we actually separated the pigments of flowers and vegetables by using paper chromatography. It's where you take the special paper and you saturate it and you like blend up a rose petal, and then you blend up a carrot and you blend up a beet, and you drop your alcohol plant juice on one end and you watch it migrate, and then you measure it, because at the end of each migration there's like a little dot. It moves and then it stops and moves and stops. Then you compare that to a standard and you put a number inside of an equation. I don't remember any of it, but you can see what compound is responsible for what color in what plant, which is really interesting because one of the discrepancies we had in science was that the blue cornflower and the rose use the same pigment. So why were red roses and blue cornflowers two separately different colors to our eyes when they were using apparently the same pigment? And it's because the blue cornflowers also contained other phytonutrients that were interacting with it in different ways, like in chemical ways, and the electrons moving around. So that there is an example of how nature takes several basic things and can reorganize it and rearrange it into a completely different outcome. And if you're really interested in what I just said, I think you can buy those paper chromatography plants online. It's not too hard. You can buy a lot of science stuff online if you want to see it for yourself how it works. So back to the wood. It's phytonutrient compounds that make it glow under blacklight. And I want to check this one thing. If this is true, that means that, of course, different species of wood are going to have different levels of these phytonutrients, these flavonoids inside of them. They're also going to be sequestered differently in the cambium layer or the heartwood layer. I guess there's a maple. One of the maples, heartwood, glows. So does the trash wood that I make lemonade out of. Staghorn sumac. Apparently staghorn sumac glows. But I hear tell that it all degrades under UV light, which stands to reason. If it's just a chemical, it's kind of effervescent or whatever. The only thing I have in my house that's black locust is this cool candlestick holder that I won for competing in a chili cook-off. I got second place in my Feast of Beasts chili. Somebody took old locust fence posts and then turned them into candle holders. And so I've just kind of kept it as a souvenir. I'm going to put my black light on it and see if this black locust wood glows. I'm going to go ahead and assume that it doesn't because it's been out, well, as a fence in somebody's yard for probably decades. It's in pretty good shape, but it's also been chilling on my counter here. So the UV degradation from this room has probably decreased its UV qualities. But if I were to nick it, maybe there's still some left in there. I would really like someone who's got a fresh piece of locust wood that they can saw through or turn to put a UV light or send it to me and I'll put it in a video. Whoa, look at that. It does glow. Let's get dark. Let's get dark. Come with me to my stairway. Okay, here we go. Closing the door. Look at that. Cool. And you can see where it's more exposed, where it's been cut. And that makes sense. Check that out. Look how much the locust wood glows. I didn't know that. Thank you for everyone in the comments who was telling me that so I could do a little bit of a deep dive. I know a bit about the phytonutrient stuff that I have also long since forgotten because that was like 15 years ago. But I didn't know about the glowing. Also, if you're on the East Coast, like not too far from me in Pennsylvania, there is a zinc mine called Sterling Hill in New Jersey. It's the Sterling Hill Mining Museum, and the mine itself shut down, but they've still got a museum, and it's awesome. You can go underground with your UV light and just like pick up old zinc silicate rocks. It's called Wellamite. It's, well, you know how like there's the proper name and then there's the you buy it off the shelf name. It's Wellamite. I think. You can go down in a mine and pick up glowing lights. You pay the admission and you do the thing. So no, not radioactive wood. I think they're flavonoids. Somebody correct me. I took an Adderall today.